Hi, and welcome to the independent practice for lesson 15.1. This one is all about negative exponents and, well, any kind of exponent. And we're simplifying expressions here. So I'll start with the first one. And to do this, I'm going to make this a little bit smaller, and we'll get this here. And I'm going to simplify it here. So in the previous lecture, I talked about negative exponents. So this is what I'm going to do is I'll show you that 5 to the negative 7th is equal to 1 over 5 to the 7th. Okay, well, you should know that now. And 5 to the negative second is equal to 1 over 5 to the positive second. So I'm going to use this here. I have, oops, I have 5 to the 12th. So I'll put this in this color. So 5 to the 12th over, and then I'll have 5 to the 7th, 5 to the 7th there, because now it's in the denominator. See that from numerator to denominator, it changes sign. And then 5 to the 2nd is our other one, so times 5 to the 2nd. And what we can do is we can see that 5 to the 12th would be 5 times 5 times 5 times 5 times 5. What? 1, 2, 1, 2, 3, 4, 5, 6, 7. Oh my goodness. 8, 9, 10, 11, 12. So there's 12 of them. And that's all going to be over. Whoops. It's all going to be over. I'm gonna okay 5 to the 7th, so that's 1 2 3 4 5 6 7, and then 5 to the 2nd is 1 2, and we can cancel out all these, and we should have 3 on the top, so that means we're gonna have 5 to the 3rd as our answer. Okay. Oh, and 5 to the 3rd is 125. So 5 to the 3rd is equal to 125 because it's 5 times 5 times 5. For the rest of these, I'm not going to do this long process. I'm going to go a little bit faster. And I will erase all my work here. And I'm going to copy this next one right there and bring it. Well, let's see. So 8 to the 12th, that is going to stay 8 to the 12th. So that's 8 to the 12th times 8 to the 7th taken to the negative second power. So what you can do with these is I'm going to tell you, you can take them, that you can multiply these exponents. It'd be 8 to the negative 14th times 8 to the negative 14th. Now, this 8 to the negative 14th right here, I'm going to place that as a positive exponent into the denominator. So this is equal to 8 to the 12th over 8 to the 14th. And what we should see here is we have, there's 14 eighths on the denominator, there's 12 eighths on the numerator, there's 2 more in the denominator. So what we have is we have 8 to the 2nd on the denominator, and we have none left on the numerator. This is what the answer is, 1 over 8 to the 2nd, or they might write it as 1 over 64. And that is this one here. You know, I feel a little bad about what I got here. Let me slow this down a little bit, because I realize that I did take a bit of a leap on this, and I don't want to shortchange you. So 8 to the 12th. Let's go back. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 eighths on the numerator. And I'm going to draw a nice straight line there. And we're going to have 8 12s in the denominator. I'm sorry, 14. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. See, that's what this whole thing means. 8 to the 12th is 12 of these, and 8 to the 14th is 14 of these. And then what we can do is we can cancel these out. Everything gets canceled out, and there is your 1 over 8 to the second, which is 1 over 64. Okay, next one is this. So what we have is, I think that what I'm going to do is I'm going to write 5 times and then 3 times. Oh, I see what they're doing here. They're doing this. They're saying that, well, what you could do is this could be times 3 to the second times 5 to the second. See that little baby 2 right there can go to each item, kind of like distributing them. And so now what you have is and I see that I have 5 times 5 to the second. Well, 5 times 5, how many 5s do you have? You have 3 5s now being multiplied. So that's 5 to the third. So these two together is 5 to the third. And then 3 to the second, is that. And then I'd probably say 5 to the third, that's 5 times 5 times 5, which is 125 times 9. Let's see. 9 times 100 is 900. And 925s is 225. Yeah, plus another 225, which is 1125. So the whole thing should be 1125. I got it. Okay, let's erase some of this stuff here. And I'm going to now do this one, 9 squared. Let's see, let's make this all just a little bit bigger here. So 9 squared over 9 to the 5th. And this is 9 times 9 over 9 times 9 times 9 times 9 times 9. And you can cancel these out. And there's nothing left in the numerator. Let's put a 1 there. And 9 times 9 times 9 is 729, I think. Because it's 81 times 9. And yeah, it is. Got it. Number 27. 27 is this right here. So let me explain a little bit about why you can multiply a power to a power. So that's 2 times, that's 6 to the 10th. But why is because of this. We can have, I'll put it in white here. So 6 squared means you have 6 times 6. And so if you have 6 squared, so 6 times 6 in parentheses. And this one right here tells me I have to do it 5 times. So there's 1 time. And here is 2 times, 3 times, oops. That's 4 times, 5 times. And then we have a line for our denominator, and 6 to the 8th is in the denominator. So 1, 2, 3, 4, 5, 6, 7, 8. See, now we can cancel. We cancel stuff. And you know what? I want to say something real quick, because I said I was going to explain this. How come you can multiply 2 times 5 and get 6 to the 10th? Because this is two of these, and you have to do it 5 times. So it's 2 done 5 times. Well, that very much is multiplication. 2, 4, 6, 8, 10. There's 10 of them. And then further, you can do, what you can do is this. You could do 6 to the 10th minus 8, because there's 8 in the denominator, and then your answer would be 6 to the second. And that ends up being true, because if I cancel all of these out, I get 2 6s here. That's 6 to the second over 1, right? But 6 to the second over 1 is just 6 to the second power. And there it is. And 6 to the second power is 36. This whole answer should be 36. Got it. And for this one, number 28, boy, there's a lot going on in this one. I'm going to copy this and bring it over here. I'm going to remove this stuff so I have some room to express my ideas. And let's bring it up here. Now, 11 to the 10th, that is, well, I'm going to go shorthand with this. 11 to the 10th over 11 to the 3. You have 3 of them and 5 of them. You have 8 of them altogether. And then you can do 11 to the 10 minus 8 for the same reason I did in the previous problem. You can subtract them. And you end up with 11 to the second. And I know that's 121. And when I do this, I should get 121. And now, ooh, boy, there's a lot going on in this one. Let's see now. Okay. I'm just trying to get rid of everything. Okay. Now, I got that. This big old mess right there. Anything with negatives, like this one here, that negative, I'm going to put that in the denominator. We know that's 1. And we know we can multiply these two. So that's 2 to the 6th. Let me rewrite this here. So this is 2 to the 6th plus 1, because 2 to the 0 is 1. Anything to the 0 power is 1. Plus 2 to the 7th times 2 to the, times 2 to the negative 5th. Let me rewrite this now. 2 to the 6th plus 1 plus, now since this is being multiplied, I have to think of it like this, because the order of operation says you have to multiply first. And 2 to the 7th times 2 to the negative 5th. Well, what you could do is you could just add these two together. 2 to the 7 plus negative 5. You can add those up. And I end up with 2 to the 6 plus 1 plus 2 to the second. Now, hold on a minute. Why am I allowed to just add those together? I'd like to explain that. As I have, I'll do this in a separate color here, that right there. 2 to the 7th times 2 to the negative 5th. Well, hopefully you can see that with a negative exponent, that becomes a positive exponent in the denominator. And I still have 2 to the 7th in the numerator. That didn't go anywhere because the exponent on this one is positive, so it stays positive. That's negative. It goes into the denominator as a positive exponent. And now what I can do is I can do this. 2 to the 7th is 2 times 2 times 2 times 2 times 2 times 2 times 2 over 2 times 2 times 2 times 2 times 2, and these all cancel right here, and it's 2 to the second, which is exactly what I have right there. Okay, so that's the reasoning behind all of that. Now, let me get rid of this stuff here so I can clean it up and put it away. Let's see. No, I want to, nope, didn't want to do that. Okay, I'll just erase this. So this gets all erased here, and I'm going to finish off the problem. 2 to the 6th plus 1 plus 2 to the second. 2 to the 6th. Let's see, 2 to the 6th. 2 times 2 times 2 times 2 times 2 times 2. I know that's 4 times 2 is 8 times 2 times 2 is 16. All right, so I've done this and this and this and this. Times 2 is 32. Times 2 is 64. So 2 to the 6 is 64. I got to erase all this stuff again. 2 to the 6 is 64. And that's 64 plus 1 plus 2 to the second is 4. So this is 64 plus 5 is, that should be 69. And let's see what we got here. Yeah, got it. Number 30. Ooh, another long problem here. Let me copy this, and I'm going to bring it over here where I can do more with it. Got a little more space. I'm going to get rid of these and move this up here. So negative exponents are going to go into the denominator. So this is 1 over 3 to the second times 7 minus 4 is 3 to the second, plus 7 plus 4 is 11 to the second power. I'll put it in parentheses just so you can see. So I did some stuff here. Now, I'm going to put these together. These two are being multiplied, so I'm going to multiply them. I have 3 to the second, and then over 3 to the second. Now look at that. I have this right here. This gets placed down here because that's in the denominator. And this one here, 3, that's the same thing as doing this. In fact, I'll put parentheses there just to make it look the same. That's the numerator. Now 3 to the second over 3 to the second, that's 9 over 9. It's the same thing. It's just 1 plus 11 to the second power. And 11 to the second power is 121 plus 1 is 122. And so that's what we should expect to have here. Yeah. Okay. We have this one here, number 31. Let me erase this and this, and I'll grab number 31. We can see part of the answer is a 1 on top, but let's see here. I would take 10 to the 4th. Okay, so I'll just express 10 to the 4th here times. What I can do is I'll leave the brackets, and 8 plus 2 is 10. I'll put that in parentheses. To the second, taken to the negative third power. You know what I could do here is I can multiply these two. That's a power taken to a power, so you can multiply those. So I'll rewrite this as 10 to the 4th times, I'll leave this in brackets, and I'm doing, that's 10 to the negative 6th power. Now when you're multiplying powers here, when you're multiplying these, you can add these two exponents together. So this would be 10 to the 4 plus negative 6, and that would be 10 to the negative 2nd, which is the same thing as 1 over 10 to the positive 2nd. That's part of the whole purpose of this lesson, is the negative exponents can turn into positive exponents if you put them into the denominator. I see it as you're passing this through the division sign, that fraction bar. If this passes to the other side, then it changes the sign from negative to positive. And also what's happening is, I wonder if I could do this. No, I can't. It's flipping over too. So this right here, this is flipping over like that, and the sign is changing. Okay, so 1 over 10 to the second, that is 1 over 100, and that's what we should expect to see right here. Okay, number 32. I will cut you out. I'm going to remove this stuff, and I'm going to move this over here. 7 to the 5th. Okay, so what I have is 7 to the 5th, and then in parentheses 2 plus 5 is 7 also. 7 to the 4th. Well, right there, I'm looking at, you can do, that would be 7 to the 5 plus 4, which is 9. Now, that's all over, and what I can do here is 8 minus 1 is 7 again. So that would be 7 to the 7th, and that's 7 to the 7th. And so this would be 7 to the 9 minus 7, which is 7 squared, and that is 49. 49. Number 33. Wow, they're just getting more complex here. Okay, I'll bring this over so you can see. And this, I think that what I would first do is the stuff in parentheses. I'll leave the brackets. Um, 4 plus 2, and in parentheses, 4 plus 2 is 6, taken to the third power, all to the fifth power. And then in the denominator, we have 9 minus 3, which is also 6 to the 12th. And then now I'm going to take that 3 to the 5th, to the 3 to the 5th. You can multiply those two. That'd be 6 to the 15th. So that is equal to 6 to the 15th. And I don't need those brackets anymore. Over 6 to the 12th, which is equal to 6 to the 15 minus 12, which is 6 to the third. And 6 to the third is 6 times 6 times 6, which I think is 216. I'm pretty sure that's right. Yes, it is. Okay, and the last of these type, what we have is, I would do what's in parentheses first. So we have 4 times, I think that what they want in this one, what's going to make things easier, is if that 3 gets distributed to both of those. So that would be 4 to the third times 6 to the third. And the reason why I'm looking at that is because I see that 5 plus 1 is 6. And that's going to cancel with this. So that would be over 6 to the third. And the reason why I'm placing it to the right there is because those will just cancel each other out. That's just done deal. And then you're looking at 4 to the third power, which is 4 times 4, 16 times 4, which is 64. And we should be looking at 64 for this one. Yeah. Okay. So, vocabulary. Identify the property that's being applied to at each step to simplify the expression. So, I have all these here, but also when they're talking about identify the property, in your textbook, they have this. The properties of integer exponents on a previous page in the lesson. Zero property, they're saying that any number to the 0 power is 1, and there's an example, 2 to the 0 is 1. Negative exponents, any number with a negative exponent is positive in the denominator, like this is happening. We've seen that. Product of powers, so when you have a product, like you multiply the powers, you just add the exponents, like 2 to the third times 2 to the fourth is 2 to the seventh. The quotients, you would subtract the exponents, like in this example. And a power of a product, so yeah, I did all of these. I've done these in all the previous ones. In power over power, this is where you can multiply the two exponents, 2 to the 3 squared to the third power is 3 to the 6, so 2 times 3 is 6, and so on. I went fast through that, but that's in your textbook. But what we need to do is we need to see, well, what happened, what allowed them to go from one step to the next. And so we have -5. Okay, that didn't change. Oh, look at that. That changed. 4 times 9 to the 5th is 4 to the 5th, 9 to the 5th. That looks like they use the one that, this one. They did this right here. It went from this to this. So that's product of a power of a product property. And so that's the first one. Next, what happened? We have, oh, look at that. We have, this looks like an associative property type thing, where the only thing they really did is they changed the grouping symbols. So let's see what they had to say there. The associative property. I was right about that. That's not necessarily in this list, but the associative property allows you to move your grouping symbols around other things as long as you're multiplying. Here, it looks like, well, that's -5 plus 5. It looks, and 5 plus -3 is 2. So it looks like they added these. So that would be the this one right here, where you have the product of powers property, where if you multiply them, that's the same as adding them right there. I would think that would be it. Let's see how right I am or wrong. Product of powers, good. And then this this one right here, anything to the zero power is 1. That's this one right here, the zero exponent property. And that's why we have this here. And then this right here, if you multiply by 1, that's called the identity property. So this is probably going to be the identity property multiplication. And then, I don't know what you say, just the definition of a exponent, I would imagine. Oops. Uh-oh. Here we go. I was right. Oh, that's funny. Anyway, okay. So Camille simplified an expression as shown. Discuss why this method is justified. Let's see. Well, what did she do? She separated them out, and then she used that product or that quotient property, right? Because 5 minus 2 is 3, and 6 divided by 3 is 2. And then, well, this is what the publisher had to say. The product of two fractions is the product of the numerators over the product of the denominators. Okay. Top times top, bottom times bottom. Writing this as a product of fractions lets you simplify them separately using the quotient of powers property. That's this right here. 5 minus 2 is 3. To simplify the second fraction. All right, so moving on to number 37. Explain why the exponents cannot be added. Well, the bases are different here. That's 12 to the third, and that's 11 to the third. So you need the same base, because the bases are not the same. List 3 ways to express 3 to the fifth as a product of powers. Well, there's many ways of doing that. Here are a few. Well, you can have, because that sum right there needs to be 5. So it's 3 to the 0 times 3 to the 3 to the fifth times 3 to the 0, because 5 times 0 is 5. 4 plus 1 is 5. 3 plus 2 is 5. So there's 3 ways right there. The distance around Earth to the moon is about 22 to the 4th miles. Okay, that's pretty far. The distance from Earth to Neptune is 22 to the 7th miles. Which distance has a greater distance? About how many times greater is it? Well, that 7 is bigger than that, and so it's definitely Earth to Neptune, and it's 22 to the third. So what you do, how many times more is it? What you would do is you would take the 22 to the 7th and divide it by 22 to the 4th, and 7 minus 4 is 3. Okay, now this student claims that 8 to the third times 8 to the negative fifth is greater than 1. Explain whether the student's correct or incorrect. I think the student's incorrect, because if I first take 8 to the third times 8 to the negative fifth, I'm going to rewrite this as 8 to the third, or actually, I don't even have to do that. And there's a bunch of ways to do this. I would probably do 8 to the 3 plus negative 5, because you can add them up since you're multiplying those powers, and that would be 8 to the negative second power, which is the same thing as 1 over 8 to the positive second power, which is 1 over 64, and that's not greater than 1. And so the publisher had this to say. Oops. Sorry. Student's not correct, because of what I was just saying. It's 1 over 64, which is less than 1. Okay. Find the missing exponent. I think this is 3, because what I need to do is a power to a power. You got to multiply those, and 2 times negative 3 is negative 6, so that should be negative 3. This one, we're adding these, so what plus 6 is 9? 3 is. That would be, all right. Oh, that was bad. 3. And this one, y to the 25th divided by something is 6. So it's 25 minus what is 6? I believe that's 19. So I would do 19. Why do you subtract exponents when dividing powers with the same base? Well, this is why. It's the same as multiplying by the reciprocal, so when dividing powers with the same base, you add the opposite of the exponent in the denominator. This is the same as subtracting the exponents. Um, yeah, I mean, that's definitely one idea. And why do you subtract exponents when dividing by powers with the same base? To me, it comes down to, if you have 2 to the 5th um, divided by 2 to the second, that's 2 to the 1, 2, 3, 4, 5 over 2 to the second, and these cancel. And so it's 2 to the third, right? And you can see that's 5 minus 2. But what they're saying is this is the inverse of, because if you have 2 to the fifth times 2 to the second, that you can add them. And so that would be 2 times 1, 2, 3, 4, 5, and then 2 more. Oh, I got a great idea. I could use the power of color to illustrate my point. Times 2 to the second, so times 2 times 2, right? That's those. So when you do this, you would end up with 2 to the 7th. And so in this, you're adding the two exponents to get 7. But division is the inverse of multiplication. So instead of adding here, you would be subtracting. That is why they're talking about inverse is the same as the opposite exponent. It's the same as subtracting the exponents. It's the same kind of idea. The mass of the sun is about 2 times 10 to the 27th metric tons, or 2 times 10 to the 30 kilograms. How many kilograms are in 1 metric ton? Well, we got this. And what we would have is the way we would get this, I'll show you, is it's simply 2 times 10 to the 30th over 2 times 10 to the 27th. And these would cancel. And it's basically 10 to the 30th divided by 10 to the 27th, which is 10 to the 30 minus 27, which is 10 to the third. And that is what we got. Number 46. In computer technology, a kilobyte is 2 to the 10th bytes in size. A gigabyte is 2 to the 30th bytes in size. The size of a terabyte is a product of the size of a kilobyte and size of a gigabyte. What is the size of a terabyte? So you got to multiply them. Oh, that's easy. So we have 2 to the 10th times 2 to the 30th, which is just 2 to the 10 plus 30. That should be 2 to the 40th. And let's take a look at that, to the 40th bytes. All right. And we have the last bit here. Where can I find it? All right, so we have page, or the last bit of problems here, number 47. Write equivalent expressions for x to the 7th times x to the negative 7th, and that x to the 7th divided by x to the positive second. What do you notice? Well, they are equal. That's the same thing. And this is what we should be noticing. Both of them are equal to each other. And when multiplying powers the same base, you add the exponents. So we would add 7 plus negative 2, which is 5. And when you're dividing, you would subtract the exponents. 7 minus 2 is also 5. So in both cases, you would get the same answer. All right. A toy store is creating a large window display of different colored cubes stacked in a triangle shape. The table shows the number of cubes in each row of the triangle, starting with the top row. Okay. Row 1, 2, 3. Okay, so the number of cubes in each. 3 to the first, 3 to the second, 3 to the third, 3 to the fourth. Fine. Describe any pattern you see in the table. Patterns. Well, for each row that increases, it raises a power of 3. That's what I notice. Raise. Okay, yeah. So what we have is using exponents. How many cubes will be in row 6? Okay, well, in row 5 is 3 to the 5th, and row 6 would be 3 to the 6th. Huh. I'm not sure exactly what 3 to the 6 is. Well, I know that 3 to the second times 3 to the second times 3 to the second. Oh, 3 to the second is, and so that's all 3 to the 6. So that's 9 times 9 times 9. I know that that's 729. Yeah. So I'm expecting to see 729 right there. Oh. Oh, okay. How many will be in row 6 and row 3? Yeah. All right. Very good. If there are 6 rows in the triangle, what is the total number of cubes in the triangle? Explain how you found your answer. If there are 6 rows in the triangle, oops, oh boy, 6 rows in the triangle here. Let's see what we have to say here. So if there are 6, so you evaluate 3 to the 6th, 3 to the 5th, 3 to the 4th, 3 to the 3rd, 3 squared, and 3 to the 1st, and added all of them together. Well, there you go. And 51, a student simplified the expression 6 squared over 36 squared and got 1/3. Do you agree with the student? I don't know. Let's find out. 6 squared over 36 squared is, well, 36 is 6 squared. Okay? So this would be 6 squared squared. Or 6 to the 4th. So 6 squared over 6 to the 4th, well, that would be 6 to the 2 minus 4, which is 6 to the negative second, which is 1 over 6 to the second, which is 1 over 36. So let's go back to this. Yeah, no, I don't think so. That is a different result for sure. Yeah, just like I said. Okay. Evaluate negative a to the n when a is 3. Okay, let's do that. So a is 3. So negative a to the n when a is 3. So when a is 3, so I'm going to erase this and make a 3. And n is 2, so it's negative 3 to the second. And I'll put that in a different color. 3 to the second. And then it's going to be negative 3 to the third. And then it's negative 3 to the fourth. And negative 3 to the fifth. All right. So if I have, let's see, I'll make it green. So negative 3 to the second, that's negative 9. Because what you do is you do 3 to the second, which is 9, and then the negative goes there. That's different than negative 3 to the second here, where that would be negative 9 times, I'm sorry, not negative 9. Negative 3 times negative 3, which is positive 9. See, that's a different result there. Now, for this one, that would be a negative again, and that's 27. And then this is also, see, the negative is going to be there every time. That's 81, and that's 729. Okay, does it appear, based on the result, does it appear that negative a to the n is equal to negative a to the n? If not, well, it looks like Yeah, it looks like it is. I'm gonna say it's a go. Um, yeah. Okay. So for negative 8 at the end, you get negative. Yeah, you get all those. Oh, 243. Hmm. Oh, times 3. Yeah, yeah, yeah. Sorry about that. I was thinking times 9. Um, so 243. Okay. So when n is even, the two expressions are opposites. Yes. So when n is even, 2 and 4, uh, two expressions are opposites. Okay. And so negative a to the n, okay, and negative a, oh yeah, they are opposites. So that's what I was showing you right here. I was showing you that when you have the negative in the front, it's negative 9, and the negative inside is positive 9. And if we did that with negative 3 to the fourth, there's a lot going on here. If I have negative 3, but I have that all in parentheses to the fourth, that is equal to um, negative 3 times negative 3 times negative 3 times negative 3. And that is equal to positive 81. And when you compare that, these are opposites of each other. But if you did it for the odd exponents, they would be the same. They'd be also 243. That's what's happening in that. And preserve and problem solving. Oh boy. A number to the 12th power divided by the same number to the 9th power equals 125. What is the number? I think it's 5. So what do we got here? We have some number to the 12th power over that same number to the 9th power. That would be some number to the 12 minus 9, which is that number to the third. So what number to the third power is 125? Well, that has to be 5. 5 to the third power. It's called the cube root of 125. And that is that. Okay, well then there you go. Wow, there was a lot going on in this whole thing here. Lots and lots of math. Look at all the stuff that we have, and well, I hope that this has been helpful. I know that exponents can be pretty tough. So thanks for watching, and bye for now.